Welcome to Ruwa Perfect classes. In this class, I will discuss about graph theory. I have already discussed videos of graph theory, some topics. Now I am going to continue. In discrete mathematics, a graph is a structure. In discrete mathematics, a graph is a structure which consisting of vertices, which consisting of vertices that is known as nodes and also known as vertices and edges. There are two nodes which are connected by this edge, by this arrow, and this arrow is known as edge. In discrete mathematics, a graph is a structure which including vertices, edges, and they are connecting each other through edges, and they use to represent relationship between objects. Graphs can be directed. This is directed graph because it gives direction, and this one is undirected because in this graph edges not giving any direction. Edges, both sides are gone. Both sides are connected to each other. They can move from A to B or B to A, B to C, C to B, C to A to C. But in case this figure, it can move from A to B because it gives direction by this symbol of arrow. So we can say graphs can be directed or undirected, and various properties like connectivity, cycles, paths, which can be defined on them. There are some properties of graphs. First, vertices. This is known as vertices. Edges, those arrow symbols which are used for connecting. These are edges. Directed or undirected. Undirected. In directed graph, direction is given. In undirected graph, there is no direction. In directed graph, edges have a direction, an arrow from vertex A to B, while in an undirected graph, edges are bidirectional. Connectivity. Connectivity, a graph is connected if there is a path between any two vertices, like this. There is a path. This is a connectivity. Cycles. A cycle is a path which starts and ends same vertex, like this. It starts from A to B, goes to C, and then goes to again A. This is a starting and ending vertex. Start and end vertex. When start and ending vertex are same, that is known as a cycle. paths. A path is a sequence of vertices connected by edges like this: A to B, B to C, and C to A. From this figure you can take path. Now next property is degree. The degree of a vertex is the number of edges connected to it like this. A, B, C. You can see here A has two directions, A to B, A to C. That means A has a 2 degree. C has no direction because A to C and B to C both are meet. A also meet on C and B also meet on C. So that's why C's degree is 0. And in B, B only goes to C. So that's why B is equal to 1 degree. Isomorphism. Next property is isomorphism. Two graphs are isomorphic if they have same structure. If they have same structure, even if vertices or edges are labeled differently. For example, we have given these 4 vertices and this is a graph, and like this it has also 4 vertices, but there are edges only 3, but vertices have 4. Two graphs are isomorphic if they have same structure, even if the vertices or edges are labeled differently. Means A, B, C, D. A, C, B, D. Both is a isomorphism because both figure have 4 vertices, 4 edges. Whether they are labeled in different way. That is known as isomorphism. Next is subgraphs. A graph is a subgraph whose vertices and edges are subset of the original graph's vertices and edges. We can take subgraph from this graph like this. This is a subgraph. You can take it like this: A, C, B, D. You can take A, C, B, D. You can take A, C, B, D. These all are the subgraph. Now next is a complete graph. Next property is a complete graph. In a complete graph, every pair of vertices is connected with the edge like this. This is a regular graph and it also called complete graph because all vertices are connected to each other. This is a complete graph. Now next topic is Eulerian graph, or you can say Euler graph. Graph. Eulerian graph is a such type of graph in which you can say Eulerian circuit. An Eulerian circuit is a closed walk in a graph. Eulerian graph is a graph which contains an Eulerian circuit. An Eulerian circuit means Eulerian circuit is a closed walk in a graph which traverses each edge exactly once. Each exactly one. Or you can say like this. A, B, C, D, E, F. A connected with B connected C connected D connected E connected A connected F connected B, and F connected C, F connected D, F connected E. A also connected through this way, E connected this way with D, B connected C, this is a Eulerian graph. In Eulerian graph, we can draw it without lifting your pen. When we draw any graph without lifting pen and tracing each line only once and returning to your starting point like this. You can see here again, you start from A, go to B, B to C, C to D, and reach their starting point without lifting your pen. This is called closed walk, and this is called Eulerian circuit, and this is a Eulerian graph. What are the main features of Eulerian graphs? First main feature is that all vertices have even degree. You can see here A also 2, B also 2, C also 2, D also 2 degree. And second feature, it should be connected graph. Means there is a path between any two vertices. And third feature is Eulerian circuit should be exist. Means closed walk exists in graph and it traverses each edge exactly once. That is known as Eulerian graph. What are the relationship between Euler paths? Sorry, Euler paths. Relationship to Euler paths. While an Eulerian graph must have an Eulerian circuit, then a graph with Euler path can also have vertices with odd degree. Means Eulerian graph should have Eulerian circuit and a graph with Euler path. Euler path means each vertices have odd degree. And in this case, Euler path will start at one odd degree vertex and end at the other. For example, you have given this graph. In this graph, currently there are 2 degrees of each vertices. But when we take two diagonals, A to C and B to D, then you can see here A has 3 degree, B has 3 degree, C has 3 degree, D has 3 degree. So that's why we can say that in Euler path, we will start at one odd degree vertex and end at other odd degree. In even case, it will be starting and ending point same and it has all vertices has a even degree. And its best example is 7 bridges of Koenigsberg problem. This is a classic problem and this problem is inspired Euler's work where graph representing the land masses and bridges. Land masses and bridges and which can be traversed without lifting the pen. Traverse without lifting the pen. If and only if all vertices have even degree. All vertices have even degree. Then we can say 7 bridges of Koenigsberg problem can be solved through the Euler's method. A complete graph with an even number of vertices. A complete graph where every vertex is connected to every other vertex will always an eulerian circuit. You can say every vertex connected to every other vertex will always have eulerian circuit. In simple terms, we can say you can imagine a drawing of a house with different rooms and hallways. If you can walk through every hallway exactly once, then return to starting room. The drawing represents an eulerian graph. Means this is a house drawing. This is one room and this is door. This is other room. This is door. This is other room, door, and this is main room. And this is also room. And this is also room, door. And this is also connected. If this is first room, this is main gate. Entrance, go there, then go there, then reach here, and after come back through this gate. Means if you can walk through every hallway exactly once and return to starting room, the drawing represents an eulerian graph. This is a eulerian graph. And what type of applications are used in eulerian graph? And where we used applications of eulerian graph in different fields. You can use eulerian graph in transportation network. Where we can use eulerian graph? In transportation. In a transportation networks. Second, you can use in network analysis. Third, you can use it in any postman problems. Etc. Now I am going to discuss next topic, that is related to Hamiltonian walks. Hamiltonian walks or graphs. You can say walks, you can say graph. Hamiltonian graph is such type of graph which includes Hamiltonian cycle. It includes Hamiltonian cycle. And this is a cycle which visits every vertex exactly once, which visits every vertex exactly once. In other words, we can say it is such type of path which starts and ends at the same vertex and touches every other vertex only once. That is known as Hamiltonian graph. Example of Hamiltonian graph. For example, we have given these vertices like this: A, B, C, D, E, F. We start from A to B, B to C, C to F, A to D, D to E, E to F. This is the example of Hamiltonian graph. Now, what are the key features of Hamiltonian graph? There should be Hamiltonian cycle, there should be connected graph, there should be Hamiltonian path. These are the main three features. First, there should be Hamiltonian cycle. Second one, there should be connected graph. And third one is there should be Hamiltonian path. Now, what are the examples of Hamiltonian graphs? A complete graph. A complete graph with three or more vertices. That is known as Kn, and n should be greater than equal to 3 is always Hamiltonian. Second, a wheel graph is Hamiltonian graph. Third, a graph where every vertex has a degree of every vertex has a degree of at least n by 2, then we can say it is Hamiltonian, and n by 2 is taken from Dirac's theorem. These three points are examples of Hamiltonian graph. First, you should keep in mind when a complete graph is a complete graph by greater than equal to 3 vertices, that is Hamiltonian, and there should be a heel graph, and each and every vertex has a degree of at least n by 2 or according to Dirac's theorem, then we can say that is a Hamiltonian graph. Which type of algorithms is used for finding Hamiltonian cycles? Algorithms for finding Hamiltonian cycles. First, brute force approach algorithm. Second, backtracking algorithm. Means we can use these two algorithms for solving Hamiltonian problem. Brute force approach, in brute force approach, trying all possible paths to see if one is a Hamiltonian cycle. In backtracking case, a more efficient algorithm which systematically explore each and every path and then pruning the branches and that don't lead to a solution. Now I am going to discuss brute force approach. Brute force approach is also known as brute force approach is also known as exhaustive search or proof by exhaustion. Proof by exhaustion. Or you can say it is a straightforward approach. Which type of approach? Straightforward. It is a straightforward approach. And it involves systematically checking all possible solutions or cases to find a solution. To find a solution, we can say that it is a straightforward approach which involves systematically checking all possible solutions or cases to find a solution. To find a solution. It's simple to understand that it can be computationally expensive and it's specifically used for solving large problems. You can say in brute force approach we study about how to try every possible solution until we get correct answer. That is known as systematic trial. Second, in brute force approach, we do exhaustive search. Means we do linear search through entire solution space without any optimization or shortcuts. That is known as exhaustive search. Third, the time complexity of brute force algorithm can be proportional to the input size, and it makes inefficient for large problems. That is computational cost. It is useful, it is suitable for problems with small solution space. Small solution space. When problem specific heuristic, when problem specific heuristic, then it can be used to reduce, it can be used to reduce the search space. Search space. And you can say that brute force method involves trying every possible solution until you cannot get correct answer. It is essentially a linear search through the entire solution space without any optimization or shortcuts. The time complexity of brute force algorithm can be proportional to the input size and making it inefficient for large problems. It is suitable for problems with a small solution space when problem specific heuristic, then it can be used to reduce the search space. For example, finding all divisors of a number by checking every integer from 1 to infinite number. That is example of brute force. Now there are limitations. Inefficiency. Inefficiency means brute force approach is very slow because it cannot be used for solving a large solution space problem. It can only use for small solution space problem, or you can say it is inefficient especially for problems with a large number of possible solutions. So that's why we can say it is inefficient, it has inefficiency. Second is non not scalable. Not scalable. As size of the problem increases, the time which is required to find a solution, it also increases exponentially. So that's why we cannot be cannot be scalable. Third, not always optimal. Not always optimal. While we use brute force approach, then it guarantees finding the optimal solution if one exists. It may not be most efficient way to find a good solution. This is so that's why we can say it's not always optimal. And now I am going to discuss what are the alternatives of brute force approach. We can use, instead of brute force approach, heuristic algorithm. Heuristic algorithm. Second, we can use greedy algorithm. Third, we can use dynamic programming. Dynamic programming. There are three alternative algorithms which we can use instead of brute force. First is a heuristic algorithm. These type of algorithms are used to solve the problem in which specific knowledge is required to guide the search, and it is used to finding good solutions without any checking all possibilities. And in greedy algorithm, these type of algorithms make locally optimal choices at every step, and which is hoping to lead a globally optimal solutions. And in dynamic programming, we can say this type of technique break down the problem into smaller sub problems, and then it is solve them efficiently, and by using the solution to sub problems to solve the larger problems. So at the end we can say that brute force approach is such a simple approach but often inefficient method to solve mathematical problems, because it guarantees a solution if one exists, and its calculation cost, its computation cost, it can be very high, especially for the large problems, because it is used only for small space problems. More sophisticated algorithms which are often preferred for solving complex problems efficiently. Now I am going to discuss second approach, that is backtracking. Now I am going to discuss about backtracking approach. Backtracking approach. Backtracking is a general algorithmic technique which is used to solving the problems by exploring all possible solutions systematically. All possible solutions systematically. And it works by increasing form. You can say it works by incrementally building a solution and abandoning it if it's found to not to lead a valid solution. The algorithm backtracks to previous steps and try a different extension of partial solution. You can say backtracking approach is a general algorithmic technique or approach which is used for solving problems by exploring all possible solutions systematically. Now I am going to discuss about backtracking's features. Backtracking's approach points, main points. First point is incremental solution building. Incremental solution building, in this we can say backtracking approach work by building a potential solution step by step. That is known as incremental solution building. Second is exploration and abandonment. Exploration and abandonment. As the approach builds a solution, it checks if current path is promising. If not, it abandons the current path and backtrack to try a different option. Means in this algorithm, when build a solution, then it checks first which path is given, that is solve your problem, fulfill your promise. If not, then it backtrack and to try a different option. This is exploration and abandonment. Third one is recursive approach. Recursive approach. In recursive approach, backtracking uses a recursive method to explore the different paths and combination of solution. Fourth one is depth first search. Depth first search. The exploration of potential solutions in backtracking is based on the depth first search policy or strategy. Next is state space tree. Backtracking can be visualized using a state space tree where each and every branch represents a possible choice, possible solutions in building the solution of particular problem. What are the applications in which we use backtracking? Most of all, we use backtracking applications. First is constraint satisfaction problems. That is known as CSPS. Backtracking is a main fundamental technique which is used for solving constraint satisfaction problem where main goal is to find the values for particular variables which satisfy certain constraints, certain restrictions. That is known as constraint satisfaction problem application, which is solved by backtracking method. Second is a combinatorial problem. Backtracking is well suited for problems which involves permutation, combinations, or to finding all possible solutions within a given set of rules. Search problems. Backtracking or can be used to find the path or routes through a space such as n queen problems, rat in a maze problems, etc. These type of problems can be solved by the backtracking approach. N queens problems. It can also solved by the backtracking approach. The n queen problem is a classic problem of backtracking algorithm. The main goal is to place n chess queens on a n into n chessboard so that no two queens threaten each other. And backtracking algorithm work by systematically trying different positions for each queen and abandoning a position if it leads to conflict with previously placed queens. This is n queen backtracking problem which is solved by backtracking algorithms. Or you can say backtracking algorithm works by recursively exploring all possible solution to a problem. And it starts by you can say backtracking is a problem with solving algorithmic technique which involves finding solution incrementally by trying different options if they lead to dead end. It's commonly used in situations where we need to explore multiple possibilities for solving a problem. We can use it for searching a path in a maze, or for solving a puzzles like a Sudoku. When dead end is reached, the algorithm backtrack to the previous decision point and explores a different path until a solution is found for all possibilities have exhausted. Backtracking algorithm works by recursively exploring all possible solutions to a problem, and it starts by choosing starting solution. Then it explores all possible extensions of that solution. If extension leads to a solution, the algorithm returns that solution. If extension does not lead to solution, then algorithm backtrack to previous solution and try again to find the different extension. And there are following steps we use in backtracking algorithm. First of all, we choose a starting solution, we choose an initial solution, then in second step we explore all the possible extensions of current solution, and in third step we find if we find extension leads to a solution, then return that solution. If we find extension does not lead to a solution, then backtrack to previous solution and try a different extension. And these steps repeat and again and again until we cannot find the possible solution. We will be explored these steps again and again. And you can say this is a backtracking approach. And there are more examples of applications in which we use the backtracking algorithms, like constant satisfaction problem, combinational problems, searching problems, sudoku problems, crossword puzzles, network optimization problems, you can say generating permutation, combination, subsets, resource allocation problems, scheduling problems, etc. There are so many problems in which we can use the backtracking approach. Thank you. In this video I have discussed about graph theory, the main topics: graphs, their properties, degree, connectivity, path, cycle, subgraph, isomorphism, about eulerian and hamiltonian walks theory, and their approaches, brute force approach and backtracking approach. If you think this is good for you, then please subscribe my channel for next upcoming videos. Thank you for watching my video.